Hello, today's lesson will focus on a query function found within Google Sheets. Essentially, this function brings the power of database querying to the worksheet environment, making it arguably the most versatile function found in any spreadsheet processing software. Let's jump in. Syntax of this function takes three arguments: data, query, and headers, which is optional. Data uses the range of cells, an array of data, anything that's found within your underlying data source. Query is using Google Visualization API query language, which is a SQL-like syntax that will be familiar to anyone who has done a fair amount of database processing. Headers, as I mentioned, is optional. It lets us customize the message we're displaying in the headers and also specify number of rows we would like to utilize within the headers. Some of the examples of this function include select and where clauses, again something really familiar to anyone who's done any SQL querying, group by clause to help us aggregate our data, pivot, really powerful option for SQL queries, and finally we can always sort our data using the order by clause. The data set that we're using is found in Natality database, and it shows just a sample of the records for babies born in the state of Illinois in 1980. We're including date of birth, calculating day of week for that date, retrieving the child's race, using the isMale flag to determine if the baby was a boy or girl. Plurality uses the number of shows the number of babies being born, and mother's age shows us the age of the mother. So let's do some querying. To start, let's see if we can calculate number of twins being born. So following the syntax of the query function, we're always starting with an equal sign, followed by the query itself. Open in parentheses, we can see the first parameter being data. In our case, all we have to do is just select our data source. Let's make it absolute, like so. And the next parameter is the actual query. So we're gonna open the query with a set of double quotes and then start writing our select query. So select. Since we're trying to retrieve number of twins, we're gonna use the count function. You can count any record, so let's use count A as an example. And for our where clause, we would like to limit it to a number of records where plurality is 2, so where column E equals 2 for twins. Close double quotes and close parentheses and hit enter. It looks like there were 182 sets of twins born out of 10,000 record sample. If we want to see the triplets, we can just change that 2 to 3 and see there were 4 sets of triplets being born. So let's change it back to 2. Let's say for the next question, we would like to retrieve number of baby girls born. We can actually utilize the same query and just change it slightly. So we're still doing our count, but we have to change our where clause. So column D, if you recall, was using isMale flag. So for baby girls, that flag is actually false. And we can see that there were 4,896 baby girls born out of 10,000 record sample used, so slightly less than 50%. Not sure about you, I'm not a huge fan of that count date header. So let's see if we can customize it further and make it a little bit more user friendly. So what we can do is we can add the label function, and within that function we're going to relabel our header, which is in our case we only have one column. So we're gonna relabel number of records being retrieved, and we're gonna call it anything we like. Let's say we would like to call it number of baby girls. That name has to be enclosed within a set of single quotes. When we hit enter, we can see the results, but you know, same results, but in this case the header is a little bit more user friendly. For the next exercise, we would like to see number of birth by mother's age. You know, could be an interesting piece of information we would like to collect. Again, we can either start from scratch or reuse an existing query. So let's see if we can reuse an existing query. I'm gonna copy it, paste it, and I'm gonna change some of our conditions here. So since we're going to be grouping or aggregating the results by a specific category, in this case mother's age, we have to select that column. So age is found in column F, so that's the one we're going to put in our select clause. We're still going to be counting something, so we're still going to be counting number of birth. We can use any column for that. Let's use column A. We are also going to be grouping our results by or aggregating by that mother's age. So I'm gonna use the group by clause. I'm gonna select or specify column F for my group by, and also I'm going to be naming both of my columns. Now I'm gonna have two columns in my results, one for mother's age, another for number of births. So the first one is going to be, let's call it mother's or mother age, and the second one we're going to still be calling number of births. So let's change number of baby girls to number of births. Let's hit enter. Excellent. So now, as we expected, in the first column we see the grouping by mother's age, and then the second column shows us a number of births or number of babies being born. In this case, perhaps that'd be an interesting statistics to look at, but again, out of 10,000 records, 1,684 records were for mothers who are still teenagers, and the oldest mother on record in this record set was 45 years old. Moving on, the next question perhaps that we would like to answer is number of births by day of week. Perhaps we need to staff our hospitals accordingly. Let's actually start from scratch for this function. So again, we're gonna use the query function. For date, we're gonna make sure that we're selecting our data range. Make it absolute. And for the actual query, again, we're starting with our select clause. We're gonna be selecting column B because that's where the day of week is found. We're gonna be doing our count on any on any column to get number of records. We are going to be grouping by that first column, column B. And for the purposes of this exercise, we would like to also sort our records to show which are the busiest or most popular days for birth. So let's make sure we're using the order by clause by number of records, so count A. We're gonna be using the descending order. And finally, let's label our columns. So count A is gonna be called number of births. And we're not gonna be renaming our first column, it's gonna remain day of week. Let's see if that worked. Looks like it worked just fine for us. So Wednesday is the busiest day. There were 1,548 births on that day. So quite some busy time as compared to Sunday, which only had 1,218 records. Which brings us to the final example that we'd like to cover in today's session. We mentioned earlier that the pivoting functionality is one of really strong features that make this query function even more powerful. So let's pivot our data. For the purposes of this query, let's see if we can pivot our burst using two dimensions. So one is by race and another one is day of week. So we're using combination of day of week as well as birth to see which days were the busiest days for birth by the race of the child. So let's start from scratch again using the query function, specifying our data. Like so. And for our actual query, we're going to be selecting column C, which shows child race. We're going to be counting records using any column. Let's use column A. We're going to be aggregating by that child race, so we're going to be saying it's grouped by column C. And the final step, we're actually going to be pivoting our data by column B, which is day of week. Let's see if this works. Looks like it did. So we can see the child race in column K, and day of week is spread across the columns, starting in column L and going all the way to column R. And we can see the breakout of child birth records by child race and day of week. Hopefully you will appreciate this wonderful function, query function, as much as I do. Let me know if you like this video and subscribe to this channel to watch more content just like this.